Hi, my name is Mike Beauchamp, and I'm going to be going over my final presentation for Data 670 Capstone Project for Section 9041, University of Maryland Global Campus, and this is the fall of 2022. My project was on vaccination statuses and if social media plays a or has an influence on people's choices to get vaccinated. So I'm going to go over the data sets a little bit, talk about the project importance, some of the goals from the project, visualizations and models, the KPIs for the project, and the project outcomes. So the first data set came from the CDC. It's a H1N1 survey from 2009 to 2010, and it was to determine whether or not somebody had been vaccinated based on some of the questions that they were asked. Initially, there was like 170 variables. That wound up eliminating that down to about 50 variables by looking at which ones were going to be important to this project and the models that I was going to be building. I also eliminated some of the variables. We wound up with a little over 70,000 observations at the end. Um, I eliminated any of the observations that did not have a H1N1 vaccination indication, so it was a null value. And I also removed any of the children from the data set, so it was only adults. I also acquired a data set of Twitter feeds that had the keyword H1N1 in them from 2009 to 2010. I added variables to that one, specifically for the time frame and the sentiment that I found using Python. And there were a little over 26,000 observations in that data set. They were joined together using geographic data, so state that they were joined together on. So why is this project important? So it costs a lot of money for companies to bring new drugs to the market. It's on average of $1.3 billion to bring a new drug, and they spend about $83 billion a year on R&D. And the pharmaceutical market is actually growing tremendously, and it's estimated that it's going to be at about $1.42 trillion in the next couple of years. The revenue streams are also very significant. So global drug spending is up to 157 billion through 2025. COVID-19 spending for 21 and 22 is 53 billion and 51 billion dollars respectively. And Pfizer, Biotech, and Moderna are making about $65,000 a minute in profit from the COVID vaccination. So there's a lot of money to be made on the vaccinations that the population is going to need in the future. So the data analytics problem that I'm analyzing with this project is to find and understand any correlation between the survey questions and the respondents' vaccination status, and whether we can use a Twitter analysis to help guide business decisions in relation to vaccine distribution. So specifically, I came up with this project because I thought it would be interesting to look at COVID-19, and then I thought, well, maybe there would be an interesting idea to try to form a baseline using H1N1, since it was really the first pandemic that mankind has gone through since the creation of the internet 2.0, where most of the internet now is actually user created content such as tweets and TikToks and YouTube. So since that time, I thought it would be interesting to create that baseline, and then you could use that to hopefully predict what would happen with COVID-19, and then maybe some of the other pandemics that we will face down the road. I know we recently ran into a scare with monkeypox, but that seems to have been has pretty much been not talked about in the news media since a couple months ago. So I selected the data based on that. I found this H1N1 survey. I found Twitter data to match H1N1 as a keyword, connected them using the state, did some data exploration, looked at the features, how many observations there were, Like I said, I added and removed some of the features and some of the observations to make the data a little cleaner, a little bit better for the models. I dealt with the NA values, transformed some of the data, then went into visualization. So looked at the distribution of some of the key features, specifically age, um, sex, marital statuses. I looked at the overall distribution of vaccines, and then looked for any interesting correlations. And I created a word cloud out of the Twitter data to see what the most commonly used words were in the tweets. Um, did that using some stemming and some stop words. And then I normalized the data for the models. I created several models, which I'm going to go over in the next couple slides. Um, and then I looked for the correlations and came up with some conclusions. So some of the visualizations here, like I said, was vaccination by sex and age group, sentiment by state, um, and then the word cloud there in the second part. There's a lot of H1N1, swine flu, info, were a lot of the words, government were a lot of the words that were included in there, children. So a lot of the words you would expect that you would see when people are questioning a new vaccine, or a new vaccine comes out and they might have issues with where they're getting their information, who to trust. So the first model was created in SAS. I created a neural network. I created a lot of models actually, and the neural network was the one that performed the best. At the end, I had 8 hidden neurons, 6 hidden layers, and the activation function was exponential. Um, it did okay with accuracy. It was around 77%. So then I also did a Python workbook using scikit-learn and grid search CB, created a bunch of models, logistic regression, boosting models, all using different parameters, and using grid search CV to run those models through those parameters in order to try to determine which model performed best. At the end of the day, it was a gradient boost model that had a learning rate of 0.01, a max depth of 3, and estimators of 1,000 and a subsample of 0.7. Um, that model actually performed okay. It had a accuracy at about 83%, so it significantly outperformed the neural network that was created in SAS. And then the last model I created actually was done in H2O.ai, which is an auto ML platform. Basically, all you do is you load your data set into the platform, and it will automatically go through and perform feature engineering, and then it will run that through, run the new feature set through a whole bunch of different models, trying to look for different ways to combine the features to get the best results. It came out with a light gradient boost model, um, and that model actually performed pretty well. Um, so I will talk about that on the next slide. The KPIs. So the accuracy score that I wanted to get for this project was 86%. I came up with that number because I found on datadriven.com a competition where some people were able to score into the 86%, which I thought was actually their accuracy, but turned out to be their area under the curve score. But I continued to use 86% as an accuracy benchmark. The H2O.ai model was able to hit 84.53, which was the best model that I produced. So it was close. It wasn't exactly what I wanted, but it was still pretty satisfactory. Specificity. So what we're trying to do here with this model is to be able to identify true positives. So the people who were able to, or who actually were vaccinated, were your true positives. And then what was predicted as being a true negative. So people who were predicted to not being vaccinated who actually were not vaccinated. That's important for this project because a company like Pfizer, at the end of the day, they want to know who's already been vaccinated so that for the next round of vaccines, they have an idea on the different features that make up the people who might be early adopters and who are already vaccinated, so they don't have to waste resources trying to create marketing plans for that segment. What we're trying to identify are the people who are not vaccinated, um, who are predicted not vaccinated and are not vaccinated. Those people, the true negatives, are the people who Pfizer needs to create their campaigns to market to, so that they could get those people to take the vaccine. So that's the important part of that. So specificity was an important score. I was trying to get to 96%. I got to 86.8% specificity. So not exactly 90%, but still a really good score with the H2O.ai model. It outperformed the gradient boost by just a couple percentage points, but still it was better. The other KPIs I had was more towards the Twitter data. The sentiment over time, um, I had marked as needs work, and the geographic trends needs work. So with Twitter, users are able to enter the location that they're in. They can enter kind of whatever, it seems like whatever they want to enter. If, for example, when I was looking at the data, if I was looking for somebody who was in Chicago, Illinois, it could say Chicago, Illinois. It could say Chi-Town. For Baltimore, Maryland, where I'm located, it could be Baltimore, Maryland. It could just be Bmore, Maryland. There were some of them where it was like over the rainbow. So there were some locations that were not useful, that had to be bucketed into an unknown state, when I was doing those. And then the actual distribution that came from the Twitter data set wasn't very good. I had gotten the Twitter data set from a third party company who has the repository of Twitter data from 2009 to 2010. They were the ones who did the search on the keyword and provided a 25,000 random samples over the year. However, when you look at the distribution of the observations, most of them were from the later half of the year and not so much from the early middle part of the year. So trying to gauge anything sentiment wise over time was really difficult. It wasn't consistent enough to give me a really good number. And the geographic trends was the same way. There were a lot of states that only had 25 to 75 comments. States like Wyoming, Alaska, and then there was states like Ohio who had a couple thousand, or California who had a couple thousand. So it wasn't really geographically distributed well either to give us a clear picture of what was going on geographically or over time. Some of the results and conclusions. The survey data is satisfactory predicting vaccination status. I found the accuracy and the specificity to come out to be very useful. Um, even the ROC for that model, for the H2O model, in the area under the curve for the H2O model was 0.84, which is a really good score. If area under the curve is a one, it's a perfectly classifies the different observations. And then 0.5 would be more of a random chance. So 0.84 was actually pretty good. And I think that model would be useful for a company such as Pfizer's marketing teams to go out and use that to segment the market. The auto ML model also, besides just giving you the best overall results, it provided those results with the minimum amount of effort. You just load the data set in and allow it to do its thing. The problem is you don't really see the background algorithms, and making any kind of parameter changes on your own are really difficult to do. So you're kind of relying on the platform to do what you're hoping is best for the model on its end. But it is nice that it only ran in about 10 minutes. When you're using that grid search CV in Python, it took a couple hours for some of those models to run because they were running 80 to 90 models at a time with all different parameters. So it was fast, and it was minimum effort. But the model, like I said, can be used to segment the market. Some of the issues I had was with that Twitter data. I I think if I was to do this over again for COVID data would be a lot easier because COVID data is a lot more relevant right now. And I think if you were to scrape Twitter at the time that it was happening, you would be able to get better location data and you would be able to get more of a timeline, more of a spread over that timeline. And I would have more control over how those samples were pulled. I didn't really have much control when the third party company provided that Twitter data. Um, so the other thing is, would the COVID-19 if there was a COVID-19 survey, would that survey produce similar results? Um, I think that the sentiment from Twitter actually was not very useful because of most of the sentiment turned out to be neutral. Some of it was positive by states, most of it was neutral by state. There was not a lot of negative, there was no overall negative sentiment. But when things like, market interrupters or something happens, such as like the Trump administration and the rise of fake news and how there's a lot of distrust in the media and the government with the data and the information they're providing. I really think that it would be interesting to do this project over again and be able to pull more information on the Twitter side, so that we could combine that back with a survey to see how much it really does affect it. 'Cause I really feel like if we did this with COVID-19, we would see a significant um, influence from the Twitter data and how people are being vaccinated and their choices that they make. So thank you for listening. I appreciate your time. Have a great day.